So hopefully that part is key at the very end, how to avoid it. Hopefully you're not here to hear about how things fail. I'm hoping that you're here how to avoid it. So let's talk about that. If we were to go out on social media right now, what would you see is the main reason why people think that we fail? It was because you use Snowflake instead of Databricks. That was the reason. Or perhaps you used a data lake instead of something else. You created a data swamp, you created a data mesh, you created a data whatever instead of a data lake. And that's the problem, okay? Or you used the wrong language. You used Python instead of Java, or you used Java instead of Rust. Are these really the reasons why we fail at projects? Well, let's talk about that. Well, just how often do projects fail? In my experience, and this is a number from Gartner as well, 85% of data projects fail. They fail to get into production for various reasons. So let's invert that and say, okay, well, only 15% of data projects succeed. Is that good odds? How many of you are going to go back to your company and say, I want to do a data project and we have 15% odds of success? Anybody going to do that? No? Because those are terrible odds of success. Absolutely terrible. If more companies knew this, they would say, we're not going to do this. We're not going to actually go out and try to do a data project because the odds of success are just so low, especially relative to how expensive a data project is. These data projects are quite expensive. So, what can we do about it? Why is this so bad? And this has been a question I've been asking myself for many years, for the past 10 years, of seeing, oh, everybody's saying it's a technical problem. Is it really a technical problem? Why can't companies create more value? So let's talk about that. I want to be clear, technology is one part of the problem. They are right. Whatever you choose, technologies you choose, languages you choose, do have a part in your success or failure. But what's more important are other things. It is a part, it is an important part, but is not the only important part. Let's talk about what those other important parts are. And to do this, we're going to answer 5 questions. We're going to answer who, what, when, where, and how. If we answer these 5 questions, we'll have significantly better odds of success because we'll have answered questions about what we need to do, how we need to do it. So let's start with these questions. Who? We need the right people at the right ratios. This is important. Who are the right people? Well, these people are data scientists, data engineers, and operations engineers. How many of you have all 3 of these in your company? Because we're going to talk about that later of just how important those 3 people are, or those 3 groups of people. A lot of times at companies, what they'll have is 1 data scientist or 10 data scientists and 0 data engineers. So you heard me talk about that right ratio. Where it's really key is these people at the right ratios, where when we have a data scientist and 1 data engineer, or 10 data scientists and 1 data engineer, or 0 data engineers, that's a wrong ratio, because companies will think my data scientists are the value producers and my data engineers, they're just there to kind of keep things running. They're the nerds that we have write some code for us. That's wrong. What we need is actually the inverse of that. What we need is 5 data engineers to 1 data scientist. And this is something I talk about in my book. This is something that even Google has talked about, that the amount of work, if you look at time, the amount of time that goes into data projects, it's far more time that goes into engineering rather than model creation and the data science side. So what we'll have is we'll have this issue of this inversion where companies will have way more people that can do smaller amounts of the work and far fewer people trying to do the larger amounts of work. And this causes a problem. We need these people at the right ratios. So this is a diagram that I like to use and show management especially, because oftentimes they'll say, Jesse, I only have budget for 1 of these teams. Which one is the most important? Well, which one's the most important? And so I created this diagram to show each one of these teams is important. There's no one single one that's most important. And companies will try to do this. They'll just say, oh, we just have enough budget, we're going to do a data science team. No, nothing else. And what happens is, as you take one of these parts out, it causes a problem. For example, if you remove data engineering from this equation, you're going to have poorly written data scientist code. With all due respect to data scientists, you've learned how to program a little bit, but your engineering skills are terrible. You know some syntax, but you don't know how to engineer things. So when you remove the people who know how to engineer things, you create these systems that in the US we call it's held together with duct tape and hope, where everything's just kind of held together. You might be seeing that at OpenAI, for example. You see a lot of things held together with duct tape and hope there. We need some more data engineering. Or let's say data science. Well, it's kind of a funny thing to put all of this effort to storing and creating all these systems and then say, oh, let's not do the thing that provides the highest value. That's an important part. Data science is an extremely important part of this. Operations. Hey, let's create this system that's really expensive, that our business relies on critically, but we won't have anybody make sure that it's up and running or maintains it. That'll work. The cloud handles our operations for us. Don't have to worry about operations anymore. It's these sorts of thinking that will get you into trouble because we need all three of these teams. All three of these teams is so incredibly important. Now let's talk about what. What is the business value? Out of curiosity, how many of you could tell me very clearly in one sentence, what is the business value of your data project? Not a lot of hands up. I don't see any hands up. Oh, I see a few hands. Oh, good. Okay, we have 0.01% of the audience saying that they can do this. Ooh. So what is the business value? Can you tell me what that business value is? This is an important thing because saying your business value will be doing AI, that's not going to work well. And yet it's happening quite a bit. Just saying I'm going to do LLMs or ChatGPT or whatever, that is not a strategy. That is not going to make you money. That is not a what. That is a how you're going to do something. So there should be a very clear path to value. It should be attainable. It should be doable. And so this is what we're trying to do. We need to do a what that says, this is how we're going to take data, and that data is going to translate into specific business value. Having a data strategy isn't enough either. We can't just say, this is what we're going to do, or this is how we're generally going to do it. Usually those data strategies I find are very high level. They've been done at a C-level, at a board level, where the board has said, we're an AI company now, and that's our data strategy. It's not a data strategy, but we do need more than this. We need to be having a plan and clear execution. We need to know how we're going to execute. We need to know what we're going to do. Next, we have to answer when. When are you going to generate value? Oftentimes, a company will do one of kind of two extremes. Sometimes they'll give this incredibly ambitious, unattainable goal of when they're going to create value. And often this comes from talking to some vendor, and that vendor has told them, if you use our technology, you could create some value in 1 month. 1 month, all it took. And that's a completely unattainable goal because maybe there was a lot more caveats to that 1 month, or that the salesperson was just trying to make a sale. And so what we have is we have this issue where the team has been told, or the C-level or the board level has been told, it just takes a month to do this, where that's completely unattainable. It's completely ludicrous to ask that. And so the team is sent on this unattainable downward spiral of never being able to catch back up. And then we have sometimes another thing on the other extreme, and that is the team is given forever. They just say, we know data and AI is the future. You go try and figure something out and tell us once you found something. that doesn't do very well either, because eventually there's either a downturn in the economy, there's a downturn for the company, there's some sort of downturn, and then all these people, C-level, board level, accountants, start looking at numbers and they say, oh, look at how much we're spending on this, on the cloud for this data. And look at how much we're spending on this data team. What are they doing again? Nothing? Oh, okay, well, we can't have that. That's why we're going to cut. So what we do need to do is we need to have generate business value on some sort of timeline. I always recommend try to find something that is doable within a good amount of time, that shows value, that also improves the team and shows what the team can do. So projects, if these take too long, they will end up getting canceled. No matter what somebody says, there's always some shift or some change. Sometimes it's a personnel change, new CEO, new direct manager, new VP, whatever. And they start to look at things and they start canceling things. This is important because we need to show value. We need to create value, and we need to make sure that the expectations are correct. Next we have where. And looks like there's some parts missing to that where. But where are we going to execute things? We need a clear plan. So just saying in the cloud isn't enough. What we do need to do is we need to say, here's where I'm going to run this. This is the technology I'm going to run it on. Here's the technology I'm going to use to serve up the data. These are all important parts of what we're going to do and how we're going to serve it up. So just just following a vendor's diagram or cloud provider's diagram is not what you want to do. Here's a dirty little secret, and I had worked at a vendor as well, so I know some of these things. When you ask, what technology should I use? Here's a use case I have, and you ask a vendor or you ask a cloud provider, what technology should I use? Guess what? They will answer, here is the technology I have. And you know what? That may, or more than likely is not the right technology for the job, but it's the one they have. And so what they're incentivized to do is to get you to use more of their technology. Not necessarily what's best for you, but what makes their usage go up. And that's an important distinction. As you look through a cloud vendor's diagram, you'll notice that it's not saying, oh, use this other technology that we don't own. It's down the line, here is everything from our offering. So do be careful there. As you work with somebody, you work with a cloud vendor, you work with a vendor, software vendor, what have you, make sure that you have somebody who's neutral, that's on your side checking over things. How? How are we going to execute this plan? So what we need is a clear plan with a singular focus. Sometimes when a team is brand new, what will happen is that they will go in 10 different directions at once. So what will happen there is the data team will be founded, or they'll be trying to do something, and they'll go in 10 different projects at once. And you know what happens when you go after 10 different projects at once? Generally, you don't go anywhere. What will happen is that you will do all those 10 things and do none of them, actually accomplish none of them. So what I always suggest is very clear focus. Focus on 1 to 3 things and get those 1 to 3 things done. Don't get bogged down going in too many different directions. I'll give you a bonus, and that is why. Why is your data valuable? Once again, the value of data is not so I could run it through an LLM or GPT. There's deeper value to that data. So the question arises, do you know what the value of your data is? Any of you know what the value of your data is? Well, that's probably because you're engineers, but you know who knows? The business. Have you ever asked the business, excuse me, what the value of the project will be? So one of the things you'll want to do is, as you work with teams, as you work with companies or within your own business, you need to be talking to the business. When they say, can you do this? You can ask the question, well, what will the value of that be? Because as you get to understand the value of that and what value you're generating, you will start to be able to say and justify what you're doing. If a C-level person comes and says, why did you spend, let's say, 100,000 euros this month on cloud? You'd be able to say, well, we did that so that we could generate 10 million euros in savings or this or that. So what we're able to do is, by working with the business closely, we're able to identify and generate specific business value showing that. This is very key, and this is one of the throwing a general recommendation for you as tech people. When you talk to business people, they don't care about Spark. They don't care about Snowflake. You know what they care about? They care about saving money. They care about making money, that sort of thing. So if we're always talking about Spark doing this, or Databricks doing that, or Snowflake doing this or that, they don't care about that. So what a big suggestion I'll make is when you start talking to them, talk in terms of savings or value generation, money generation, that sort of thing. That this project generated 10 million euros. And so one of the things you'll see, I generally look for a 10x ROI. So if you invest €1 million, I would expect you to get 10 million euros of either savings or value generation there. And the reason for that is, even if the business overpromised and even if you haven't quite hit it, you'll still be at least a 1-to-1 ratio where you can justify what you've done. So you've heard the questions. It sounds like a few of the questions you don't have the answers for. So what I would suggest is, when you go back to work on Monday, start going back through these questions, because the answer to these questions may be the answer or the reasons why you're having failures or problems in your company already or in your project already. Then move back into execution, but answer these questions. Another thing I'd like to make sure you know is that not all problems and gaps are in technology. So oftentimes when we look at systems or what we're trying to do, everybody just thinks of, oh, we're missing this piece, we're missing Spark, we're missing Snowflake, we're missing whatever. But that is one part, as we talked about. But oftentimes the bigger issue is the piece that we're missing of people and gaps in skills and technology. It's really important that when we're doing data and AI technologies, it's not just, hey, let's add that new thing in. It's about organizational change and skill change. The people on the team may not have the skills or may not ever be able to have the skills to do this. It's an important thing to look for. Another question you should ask yourselves is, should you get help? There's all sorts of different ways of getting help. One of the key points I'd like to make to those listening is, as you hear these problems, and if you see these problems in your company, these problems don't fix themselves eventually. There isn't a time heals all wounds or fixes all problems sort of thing. It's only through concerted effort that you will fix these issues. If you don't put this concerted effort in, you won't be able to fix these. They will just stay there. So really key, if you see these problems, you have to put effort into fixing them. There's various ways of doing this. You can do it by yourselves. You can outsource for some help. You can get some technical consulting, some management consulting, various ways, but they require specific effort. I'd like to introduce a concept you probably heard me use just a few times in here, and that's to invert. You might have heard of this before. There's a guy named Charlie Munger. Maybe he isn't as popular here in Europe, but he works with Berkshire Hathaway, he works with Warren Buffett, and he's the other half of that, or something like half. But anyway, he says to invert. So when you try to think about a problem, instead of thinking about it directly in the question, invert the question. So let's take a look at a few questions that will invert. So if you're a data scientist, answer this question. How good is a data engineer at a data science task? Think about that for a second. Sometimes it doesn't even take that long. You think, oh, they're terrible at it. Okay? Well, how good is a data engineer at creating a model? Not great. So we've inverted the question, and you can quickly see, oh, okay, not very good. Okay, now let's do the same thing for a data scientist. How good is a data scientist at a data engineering task? And what often happens here is that the data scientist says, oh, I can do that. But they don't actually think about it the other way of, oh, I'm terrible. Or those data engineers are terrible at these data science tasks. But then they think, but I can do that data engineering. I can Google around, and I can look on Stack Overflow, and I can fuddle around. So this is the way we invert these questions. We start to ask the question, well, guess what? The data scientists, generally not very good, in fact, by large, terrible at these problems. If you want to go take a look at that, I have an entire talk where I do about what does it look like when a data engineer or data scientist does data engineering, or when data engineering team is missing. So here's another inversion. What would the business say if your data project was canceled tomorrow? So just kind of in your mind's eye, think about on Monday, you go in and the company announces that your data project has been canceled. What would the business say at this point? Will they say, what data project? Will they say, Will they give a meh? Or will they say, are you guys crazy? We need this. We use this every day. I was sitting down to look at a dashboard or look at the results of a report. I absolutely need this. This is critical. So if you don't have a absolute critical response from the business, then you haven't really connected and you haven't really generated a lot of business value. And that is key, because if there's a meh to what, you haven't been generating very much business value. You may have been doing things that the business does not care about. Now, you might be sitting there thinking, hey, but I need to do that ETL, and the business is never going to care about that. Completely right. Some parts of this, business just does not care about. But what's key here is that, yeah, you need to move off that ETL and do something else with that data that is interesting. And if you never do that, then the business is going to say, whatever, doesn't really matter. So why shouldn't you copy someone else's architecture? Sometimes when you go to a conference, people will, I'll see them though, somebody will put up their architecture and people will take the picture and they'll say, oh, I'm going to do that. That's our architecture now. We are going to do that. Well, what's interesting about that is Uber was nice enough to show their architecture over time. There's a link there on the bottom if you want to go read that. So they have a generation 1, a generation 2, and a generation 3. The architecture isn't as important as this, but what's important here is that the architecture changed over time. There was a gradual increase in complexity, and there was a gradual increase in the team's abilities and the company's abilities to execute. There was a lot of parts to this. But suffice it to say, they did not go from 0 to 150 kilometers per hour. They went from 0 to 10 to 20 to 30. They gradually ramped up their complexity. And that's key. So one of the reasons why I would suggest you not try to copy somebody's architecture is that they gradually increased that complexity. They didn't just go directly to it, they gradually increased that. So don't over-engineer things, don't copy, only move when necessary. Move up in complexity when necessary. There is another part to this, and you're probably thinking, well, what are the best practices? So that's been a key part of what I've been asking and looking for. The link to this, to the results of the survey is there. And one of the important parts to this is I wanted to figure out what sort of value are they creating. So there were 81 respondents. This was in early 2023. And what I wanted to do is to really kind of split up the groups into the worst and the best, because I was curious why a company would be the worst and why a company would be the best. And that worst and best distinction was based on the business value. So I asked them two questions. I asked them a question of what would the business say was the value you created, and what would be the what do you think is how much value you created? And so based on adding those two up and starting to break it down, I looked at that. You won't be able to see this because it's kind of, well, actually that's pretty big here on the screen. So on this one, as you can see from the legend, we have low value creation there in blue and high value creation there in red. So one of the important parts to this that I want people to understand and realize is that low value creation and high value creation teams, they both experience the same sort of problems. So question was, what is the biggest challenges that you have? And so I broke that down into, here are the biggest challenges they faced. Well, guess what? They both faced the same sort of challenges. And we'll talk about why that was important in just a second. But if you look there to the right, they also faced some issues that were more advanced. It was things like getting things into production, missing data science team, decommissioning legacy things. So the point that happened here is, by being a high-value team, they were able to generate enough business value or get enough maturity to where they started hitting more advanced things of how do we get out of this legacy product. But as you see there, they faced many of the same challenges. But you can also see there in the middle that the low-value teams experienced some challenges that the high-value teams didn't. And that was specifically on security and privacy. But the biggest one is inability to execute. That's what happens when you are a low-value team. There's this very specific inability to execute. So they often faced similar challenges. What the difference is in those challenges was how they dealt with them. They kept on going. They kept on trying to create value. So that was the key insight that I saw from this. You're going to face the same challenges, whether you're a big company, small company, whether you're a mature team, data team or not, you're going to face those same challenges. There's always going to be a challenge of friction. There's always going to be missing technologies. What the high-value teams did was they actually addressed it. They actually got something into production. We also have our methodologies that the high-value creation teams use more methodologies. It isn't saying one of these methodologies is better or worse. It's saying that a methodology helped them kind of stay on the track, stay on the rails, and generate value. That was an important part of this. And then the number of teams. You've heard me talk about this, about the importance of teams. Well, here's the visualization of it. When you have a high-value organization, high-value generating organization, you notice that they had 2 or 3 teams. They had data science, data engineering, and operations. And the low-value creation teams, they would have 1. And that is how you generate value. You get all 3 teams, or representatives from all 3 teams. Then we have best practices. It's probably too small of font for you to read those best practices. You can go to the page and you can read it. But those best practices, you see that the high-value creation teams are far more represented in using best practices than their low-value creation counterparts. So what is another distinguishing factor? It is the fact that they used far more best practices than other teams. So that brings us back to this unifying thing. What we need are data teams. We need data science. We need data engineering, and we need operations. So data science, we have that. We have that data scientist. They're creating models. They have a mathematical background. They've learned some programming, some coding skills, and can use that mathematical background to create models. Data engineers, my definition of a data engineer is a software engineer who has specialized their skills in data and big data. Operations, an operations engineer, they are people who have refined their operation skills to know how to operate some of these big data frameworks and data frameworks. All of three of these things together, they create value from data, as you just saw in that diagram. So there's a lot to this. I've written a book about it if you want to read it. It's called Data Teams. And in data teams, there's a few things that I'm really proud about. One of the biggest ones is you obviously see that I have researched a lot and I have a lot of opinions on this, but I didn't want the book to just be my opinions. So what I did was case studies. And I did case studies of companies who had 10 plus years of experience on running data teams. So I share that in there of, okay, this is what they did. Twitter, for example, Twitter, before it became X and had all its problems, that's one of the case studies. They've been doing data for a long, long time. And I wanted to be able to share, these are the issues, these are the things that they hit and at various parts. So with that, I'd like to thank you for being here, and we'll open it up to questions.